Coordinate geometry is the study of geometric figures by plotting them in coordinate axes. So the coordinate axes would be x and y axes. Okay? And now before we get into anything more complicated, we are going to go through the fundamentals, and that begins with the gradient of a line. As all of you might be familiar with from CSEC days, the gradient of a line is the measure of the steepness of a straight line. The gradient of a line can be either positive or negative and does not need to be a whole number. It can be either an uphill, which is a positive value, or downhill, which is a negative value. And let's start with how to find the gradient of a line. So the letter or the symbol for the gradient of a line is m. Okay, so it is given by m. And the formula is y2 minus y1 over x2 minus x1, where x and y are actually the coordinates of 2 points on this line. So we find 2 points, and the coordinates are x1, y1, and x2, y2. So once we know these 2 points on that line, we can calculate the gradient m. Alright? However, there are a few things we need to note. 2, in fact. So parallel lines will always have the same gradient. And the second thing is the relationship between the gradient of a perpendicular line, 2 perpendicular lines, would be given by m1 is equal to minus 1 over m2, where m1 is the gradient of the first line and m2 is the gradient of the second line. So in simpler terms, all this means is if 2 lines with gradients m1 and m2 are perpendicular to each other, meaning like this, so this is one line and this is one line, m1 multiplied by m2 is equal to minus 1. So the products of these gradients would be negative 1. Okay, so always keep that in mind. And note that this is the relationship between a tangent and a normal, which we will get into soon. The next thing we're going to learn is how to find the equation of a line. So we all know that the general equation of a straight line is denoted by y is equal to mx plus c. And I'm 100% sure you all know that because we had to go through it a million times for CSEC. So y is equal to mx plus c, where y is the y coordinate, m is the gradient, x is the x coordinate, and c is actually the y-intercept. What is the y-intercept? It is where the line passes through the y-axis. So this is the y-axis. This point here would be the y-intercept, and that would be c. Okay? There are 2 methods that we're going to learn to find the equation of a line. The first method is using the general equation of a line, which is y is equal to mx plus c. And the second one, yes, you need to memorize this, and I'm sure you already did, is using y minus y1 is equal to mx minus x1. But let's start with the first method, which is using the general equation of a line, y is equal to mx plus c, which of course is the simpler method, given that you have the means to actually use it. So if the gradient of a line is m1, and the point P is x1, y1, and it lies on the line, we can substitute these values into y is equal to mx plus c. Very straightforward, right? And we can find the value of c, and then, of course, we could find the entire equation of that line. So let's look at an example. Find the equation of the line parallel to y is equal to 3x plus 7 and passing through the point 1, 5. So that would be x, that would be y. X is 1, y is 5. Okay? Notice the key word here, parallel. So we can recall this. Parallel lines have the same gradient. So from the given equation, y is equal to 3x plus 7, we know that the gradient of the new line is 3. And why is it 3? Is because remember y is equal to mx plus c. So m would be in the position of the 3. So we know that, right? So keep that in mind. Now we're going to substitute m is equal to 3 and the point 1, 5 into y is equal to mx plus c to find c, which is the only thing we actually need to find now to find the entire equation of this line. So let's do that. Y is equal to mx plus c. We know that y was 5. M, understanding from parallel lines that we have the gradient being 3. 1 from the x-coordinate, and c, which is what we need to find. So, of course, simplify everything. We get c is equal to 2, and therefore the equation of this line is y is equal to 3x plus 2. Method number 2. Using y minus y1 is equal to mx minus x1. So m is actually the gradient of the line, and x1, y1 are the coordinates of the point that are on the line. So we have this example here. Let's go through it. The example states, find the equation of the line passing through the points -2, 7 and 4, 5. So what do we actually need to find the equation? The first thing that we need is the gradient. Then we need a point on the line, and we already have 2. All right? So the first thing that we're going to do is find the gradient of the line. Remember that we're going to try to plug it into this, right? So all we actually need is 1 point on the line, which we already have. We have 2. And now we need to find the gradient. Okay? And finding the gradient is what we learned first in the video. And we know that we can use the 2 points given, because we need the 2 points, because m is equal to y2 minus y1 over x2 minus x1. Always map out which one is y2, y1, x2, and x1. I don't want to hear that you got a mark off because you didn't know which one you were doing, okay? So also remember that these are negative signs. So always put them in brackets if it is a negative number you're dealing with, because this will become positive in the end. So let's substitute everything, simplify it to get -2 on 6. 6 because minus and a minus is a positive. And then we get -1 over 3. Step 2 now, to find the actual equation of the line, we substitute the gradient that we found, which is -1 over 3, and either of the points. I always suggest choosing one that's easy in your head, and then that'll be fine. So in my case, I think I choose, okay, so I choose 4 or 5, obviously, because it was positive. It's just easier for me to work with positive numbers naturally, so for most people, unless you're kind of strange. I'm not judging. Anyways, y minus y1 is equal to mx minus x1. Now let's substitute these 3 values and then simplify. And then we end up getting y is equal to -1 over 3x plus 19 over 3. And then we know y is equal to mx plus c. C is actually the y-intercept. So our y-intercept would be 19 over 3. So therefore, the equation of the line passing through the points -2, 7 and 4, 5 is what we solved for. The next skill that we're going to learn is the midpoint of a line. So let's say we have a line AB, and A has the coordinates x1, y1, and B has the coordinates x2, y2. And we wanted to find the exact middle of this line. Sometimes we're going to have to do that in past papers and then apply it to different things. So pay attention to this. Yes, you have to memorize this formula. So to find the midpoint, we have a formula. We have to add x1 and x2 divided by 2. And then we have to find y1, y2, and then divided by 2. And that makes sense, right? So always know that this would be the x-coordinate, the y-coordinate, just like how we always learned. And that's how you find the midpoint. The next thing that we're going to learn is how to find the length of a line. And notice the notation. So we have these 2 lines that represent the length of a line AB. So if we have a line CD, connect this here, and we wanted to say that we want to find the length of that line, we would say CD with these 2 lines on the sides of them. And that just means that that value that would be equal to would be the length of that line, CD. Okay? So that's just notation. And the formula is just the coordinates plugged into this equation. So we have x1, y1 being the coordinates of A, x2, y2 being the coordinates of B, and then we simply simplify them by plugging them into this, simplifying it, and we have the length of AB, or any line that you want to find. And it's as simple as that. Now we're going to go through circles, and we're going to focus in on circles because circles are a huge part of coordinate geometry, and we're going to go through the fundamentals by learning the anatomy of a circle first. And we're going to go through 5 main features of a circle because these will show up a lot in your past papers as well as maybe your actual paper. So the first thing is the circumference of a circle. The circumference of a circle is the perimeter of the circle. Okay, and of course we have a center of that circle as well. If we find the exact center of that circle and then go towards any point on the circumference, we're going to find what's known as the radius. So the radius, which is denoted by a common letter R, is the distance measured from the center of the circle to any point on the circumference. Okay, so this is a radius, this is a radius, this is a radius, and this is a radius. Now what if we double that radius? We will find the diameter. So the diameter of a circle is a line passing through the center and it touches 2 points on the circumference. So just a straight line passing through the entire circle, but it passes through the center. Okay, so this is not the diameter. However, this is because it passes through the center. Always keep that in mind. So we can go and realize that D is equal to 2R, common letter D, is the diameter. Then we can look at the tangent to a circle. The tangent to a circle is a line that passes through only one, and I say only one, point on the circumference of that circle. So this is a tangent, this is a tangent, this is a tangent, as long as it passes through only one point. And if we had a line perpendicular to that tangent, we call that the normal. So the normal to a circle is a line that passes through the center of the circle, again the center, and is perpendicular to the tangent of the circle. Remember in the beginning what I mentioned about the relationship between the tangent and the normal, which is very important. So m1 is equal to minus 1 over m2, which m1 and m2 are the gradients. The equation of a circle can be calculated depending on if that circle has a center 0, 0 or otherwise. So the equation of a circle differs depending on whether or not the center is the origin and the origin is the coordinate 0, 0. So let's look at when the center is 0, 0. So we see 0, 0 here, center, and that's the radius. Okay, the radius is R. If the center is the origin, we have to use this equation, which is x squared plus y squared is equal to r squared. R, of course, is the radius. So that's the center 0, 0. And when the center is not the origin, so if it's anything else, let's just say a, b for now, the equation of the circle is given by x minus a plus, well, x minus a all squared plus y minus b all squared is equal to the radius squared. And that is where a, b is the center. So now let's go through the general equation of a circle. If we were to expand x minus a all squared plus y minus b all squared is equal to r squared, we would be able to find the general equation of a circle. So the general equation would be x squared plus y squared minus 2ax minus 2by plus a squared plus b squared minus r squared is equal to 0. And this can be represented by any constant c. So let's take a note. For an equation to be considered that of a circle, it must meet certain criteria. So let's look at this. X and y must be raised to the second degree, so x squared and y squared. The coefficients of x and y must be the same, so in this case is 1x squared plus 1y squared. If there's nothing in front of it, that just means 1. Always remember that. And there are no terms in xy, meaning there's no xy, so 2xy plus 3xy, anything like that. There's no xy. If there is, it will not be considered the equation of a circle. So from the general equation, we get r is equal to the square of a squared plus b squared minus c. So let's look at an example. So it says to find the equation of the circle with a center at the point 4, 5 and the radius of 3 units. So center 4, 5, radius 3. Alright, so the equation of a circle with a center that's not 0, 0. So we know that the center is not 0, 0, so we use this formula. We were given each of these values, therefore we can substitute them into the equation. So this is the equation and we substitute in. So we have x minus 4 plus y minus 5. Notice that these are negative, so always be mindful about the positives and negatives. I'm telling you, always be mindful. And the radius is 3, so we're going to square that, and then we end up with this. So if we wanted the general equation, we would expand each bracket and then simplify. Okay? So it just said find the equation, and then say find the general equation, so we didn't have to do that. But so this could pass for that. But if we wanted to, we would just expand it. So it's very, very simple. The next thing we're going to learn is how to find the radius and the center of a circle. So from either form of the equation of a circle, we are able to find the radius and the center of a circle. So let's look at these examples. So find the radius and the center of the circles. So let's look at number 1. X minus 3 all squared plus y minus 4 all squared is equal to 25. So from x minus a all squared plus y minus b all squared is equal to r squared, we know that the x-coordinate of the center would be 3, and the y-coordinates of the center would be 4, and then 25 would be equal to r squared. So all you're doing is mapping onto the equation. So look at this and just map onto that equation there, and we're able to find the coordinates and the center very, very easily. The coordinates of the center very, very easily, as well as the radius. So the radius would actually just be r squared is equal to 25. So the square root of 25 would be 5. So we know that the radius is 5. Looking at the second part, x squared plus y squared minus 4x plus 6y plus 6 is equal to 0. We can see that from the actual general equation, minus 2a is equal to minus 4. Minus 2b is equal to 6. So therefore, we just simplify and a is equal to 2 and b is equal to minus 3. And therefore, the center, which is ab, would be 2 minus 3. So now to find the radius, all we're going to do is remember this equation, substitute what we already have, and then solve for r. And we know that the radius would be the square root of 7. Finding the equation of the tangent and normal to a circle. Now, although the tangent and normal have their properties regarding the circle, always remember that they are also just straight lines. So recall that if we want to find the equation of a line, we either need 2 points on that line or 1 point on that line and the gradient. Now let's look at this example to apply what we know. Find the equation of the normal to the circle x squared plus y squared is equal to 5 at the point 1, 2. So what do we notice about this here, the equation of this circle? X squared plus y squared is equal to 5. We know that when the circle has a center 0, 0, it looks very similar to this, right? So let's keep that in mind. From the equation, we know that the center of the circle is the origin 0, 0 because of the way that it looks. To find the gradient of the normal, we can use 2 points, 0, 0 and 1, 2, as they both lie on that line. So look at this. This is a line, and it has 0, 0 and 1, 2. So we're going to use these 2 points to find the gradient m. We're going to simplify and get the gradient to be 2. We can now find the equation of the normal using m is equal to 2 and the point 1, 2. To do that, we simply substitute into this equation, which is y minus y1 is equal to m x minus x1. So we have 1, 2. So substitute in here 1, 2 with the gradient that we found, and we get y is equal to 2x, and that's the answer. So the second example states to find the equation of the tangent to x squared plus y squared plus 8x minus 4y plus 17 is equal to 0 at the point 1, 5. So this is the equation of the circle, and this is the point that the tangent is passing through. So let's look at this equation. We know that this is the general equation of a circle. And from the general equation, we could find the center simply by mapping the values. So we know that this is minus 2ax. So we know that 8 is in the position of minus 2a, so we can equate them. And the same goes for minus 2b. We have minus 4 in the position of minus 2b. So we're just going to map them, equate them, and then simplify for A and B, which turns out to be the center of that circle. So we get minus 2A is equal to 8, minus 2B is equal to minus 4, and hence A is equal to minus 4 and B is equal to 2. So the center is minus 4, 2. So using the points minus 4, 2 and 1, 5, where we get 1, 5 from? The question. So we have 1, 5. We can find the gradient of the normal. Remember, we needed 2 points to find the gradient, and now we could find the gradient of the normal, which is perpendicular to the tangent. Remember the relationship. From the relationship between perpendicular lines, we can find the gradient of the tangent. But let's find the gradient of the normal first. Then, using the gradient of the normal, we can find the gradient of the tangent, because we need to recall that the gradient of the tangent is just equal to minus 1 over the gradient of the normal. Okay, so the gradient of the normal, we use in these two values. We have x1, y1, x2, y2, plugging them in here, substituted everything, and simplified to get 3 over 5. And then we're going to use this relationship to find the gradient of the tangent. So minus 1 over 3 over 5, and then we get minus 5 over 3. Now we can find the equation using this formula, and we can substitute what we found, which was the gradient, and we can use the 0.15. So we have y is equal to y1, y minus y1 is equal to m, x minus x1, and we have the points and the gradient. Now we're going to substitute it to find this, or we could multiply throughout by 3 to remove the denominators. It's the same thing. Points of intersection. A point of intersection is simply a common point between two functions. So this could be two lines, two circles, or a line and a circle within this context. So this means that they meet each other. At this point, the two functions take on the same value. So let's look at intersection of a line and a circle. A line and a circle can intersect in 3 ways. No intersection, intersection at 1 point, or they intersect at 2 points. So to solve for the point of intersection, all we have to do is solve the two equations simultaneously using substitution. Then, to determine the amount of times a line intersects a circle, we can look at the quadratic formed after that substitution. So let's look at the different scenarios. We get a little visual idea of what they look like. If there is no intersection, in the case that the quadratic ax squared plus bx plus c is equal to 0, if the value of b squared minus 4ac is less than 0, there is no intersection. So this line will not touch this circle at any point. However, if b squared minus 4ac is equal to 0, there is 1 point of intersection. So it passes through at actually just 1 point on that circle. It could be anywhere on that circle. We don't know exactly, but there it will be at 1 point. Okay? Then, well, of course, this line will be tangent to the circle in that particular scenario. So if there are 2 points of intersection, this would mean that b squared minus 4ac is more than 0. So if you have this and this value is more than 0, there are 2 points. If this value is equal to 0, there's only 1 point of intersection. And if it is less than 0, there's absolutely no points of that line going through that circle. So always remember that. Now let's look at this example. The example states to find the coordinates of the points where the circle, and then they give the equation of the circle, meets the line, and they give the equation of the line. So how do we find that? In order to find the points of intersection, we need to solve the two equations simultaneously. To do this, we're going to substitute the equation of the line into the equation of the circle. So notice that the equation of the circle has a y in it, and so does the equation of our line. So what we're going to do is say that since y is equal to this, we're going to substitute it into where there is a y in the equation of a circle. And as you can see here, we already did that. So we replace y with minus 2x plus 4 in the equation of a circle. And this is actually just the equation of the line. So we're going to simplify it and realize that we get a quadratic. So we're going to factorize the quadratic to solve for x. And how do we find the y values? All we do is substitute it into either of these equations. I would always choose the simpler one, in this case being the equation of the line. and we substitute both the x values. So we get y is equal to 18 over 5, and then when we substitute this one, we get y is equal to 6. So our points of intersection would be 1 over 5, comma, 18 over 5, and minus 1, comma, 6. So for 1 over 5, 18 over 5, and minus 1, 6. So that would be our points of intersection, which is the solution. The intersection of two circles. Two circles can intersect in any three ways. The first being touching externally, the second touching internally, and lastly, thirdly, complete intersection. This means that there are 2 points of intersection. To solve for the points of intersection, we can solve these two equations simultaneously by using the method of elimination. So let's look at these scenarios. Let's visualize it a little. The first is touching externally. When two circles intersect externally, they share a common tangent. So we recall that a tangent passes through one point of a circle's circumference, and we know that the circles will intersect at one point. So that's the point there, and this is their common tangent. Now, looking at the circles touching internally, when two circles intersect internally, they also share a common tangent. So this would be the common tangent here, and this circle is actually inside the circle, and this is the point of intersection. So a tangent passes through one of the points, the circle's circumference, one point of a circle's circumference, and we know that the circles intersect at one point here as well. So one point, even though this one is inside this one, is the same tangent as well. And the last one is actually 2 points of intersection. So complete intersection. This is where the circles have 1 point, 2 points of intersection. So in this instance, the circles overlap and there are 2 points of intersection. Now let's look at an example. Find the point or points of contact of the circles. So point of contact is the same thing as the point of intersection. When they contact is when they touch, when they intersect, same thing. So we're given the equation of C1 and the equation of C2, and sketch the two circles showing their points of contact. So the first thing that we're going to do is actually just find the points of intersection. So to find the points of contact, we need to solve the equations of the circles simultaneously. The easier method would be elimination though. Alright? So equating equation C1 and C2. That means that we're just taking equation C1, put in an equal sign, and saying is equal to C2. And we could do that because we want to find the point of intersection. Okay? So we're going to move all the terms to one side and it will be equal to 0 on the other side. And we're going to simplify it. Simplifying just means crossing out, doing addition, subtraction easily, right? Then we get y is equal to minus 6. So to find the x coordinates of the point of contact, we substitute the y value in either C1 or C2. Doesn't matter which one. So we have the y coordinate already and we just want to find the x. So let's say we chose C1. We substitute y is equal to minus 6 into C1, and we solve for x, and that would be equal to minus 3. So we know that the point of intersection would be minus 3, minus 6. And it was easy. All we did, again, was equate C1, C2. After doing that, we put everything to one side. When we put everything to one side, we get a value for y. Y would be the y coordinate of that point of intersection. When we get that y coordinate, what we're going to do, substitute that y coordinate into either one of the circle's equations, solve for the x coordinate, and then we have xy, which is the point of intersection. So it's as simple as that. Now to sketch the circles, we just need the center of the circle and the radius of the circles. So looking at C1 and C2, looks very familiar, right? We know that the equations we can easily map on to find the center, because we know that minus 2a, looking at the general equation, remember, minus 2a is equal to 6, minus 2b is equal to 4, remember we did this before. And in this case of C2, minus 2a would be 6 here as well, and minus 2b would be 8, just looking at the positions. Okay, so the center would be when we simplify for a and b, and we find that, and the radius is also simple because we plug it into this formula. Please remember that this is a negative sign. Very important to remember this is a negative sign, because when you're plugging it in, you don't want to make a mistake with your signs. Okay, so the radius would be 4. for C1 and the radius would be 2 for C2. And all you do is simply do a quick sketch on the graph, and it's very, very easy to do that. So this is how it should look in the end. The final topic that we're going to go through before we get to past papers is parametric equations of a curve. Now this might be us treading slightly out of our comfort zone and things that we are familiar with. So just stick with me and hopefully we are going to be okay. So the parametric equations of a curve, f, so f is a curve with coordinates x, y, that passes through the point P is the point with the coordinates x, y, are expressed in the form x is equal to g of t and y is equal to h of t. So t is actually just a third parameter or variable, okay? So parametric equations are called as such because they express the x and y coordinates in terms of another parameter or variable. So let's look at how we find the parametric equations given the Cartesian form. So the parametric equations of a circle are given by these two. X is equal to r cos theta and y is equal to r sin theta. So where r is the radius of the circle and the center of the circle is 0, 0. However, if the center of the circle is not 0, 0, that is AB, the parametric equations are given by this instead. So x is equal to a plus r cos theta and y is equal to b plus r sin theta. So we have plus a here and plus b here instead of just it alone if the center was the origin 0, 0. So where r is equal to the radius, a is equal to the x coordinates of the center, and b is the y coordinates of the center. Now let's look at this example. This is an easy one. The Cartesian equation of the circle is given as x squared plus y squared is equal to 16. Find the parametric equations of the circle in terms of theta. So the solution is as such. X squared plus y squared is equal to 16. So we can recall the equation of the circle 0, 0 is given by x squared plus y squared is equal to r squared. Now, y 0, 0, remember the center would be 0, 0 because of the form. So r squared is equal to 16 based on the form as well. And we can solve for r by simplifying it, which is the radius. Therefore, the parametric equations of the circle are given by x is equal to 4 cos theta and y is equal to 4 sin theta. All we did was substitute it here, looking at this. And this is because r is the radius and the center of the circle is 0, 0. This is for this particular equation, okay? Now, another example. A circle has parametric equations. X is equal to cos t plus 2 and y is equal to sin t minus 5. Find the Cartesian equation of the circle. So now we are given these two. We can make sin t and cos t the subject of the equation. So we're going to do that. Using these two equations, we just transpose in for these two. Recall that the Cartesian equation of a circle is given by this, okay? So we can apply our identity. Yes, identity. I told you identity is going to come up after as well. So here we are. We're going to apply this identity to find the Cartesian equation of the circle. So we're going to square the equations 1 and 2, which is what we created here. All this means is that it's labeling the equation. So this is labeling equation 1. This is labeling equation 2. So you do it like that. We're going to square them. And when you square it, remember we square in both sides. So it'll be sine squared t is equal to y plus 5 all squared. Squaring it here again and squaring it here again. So we're going to add both equations. And to add both equations, what we're going to do is add the left-hand side to the left-hand side and the right-hand side to the right-hand side. And we're going to simplify. So therefore, the Cartesian equation of the circle is given as this, which is what we just simplified to. Now, an alternative solution, we can recall that the parametric equations of a circle with the center AB is this. Remember from above, we can just refer to this, where the center is AB and not 0, 0. Looking at our equation, so we remember the equations, it is implied that 1 is in front of both of these terms. Remember, I mentioned that earlier in the video. If there's nothing about, like in front of a variable, it just means that there's a 1 there. It just means 1 multiplied by that variable. It means itself, right? So the x coordinates of the center is 2 and the y coordinates of the center is -5. Remember that. So therefore the Cartesian equation of the circle is, and it's the same exact thing. So it's very simple. All we had to do was look at that and notice that the coordinates of the center would be 2, the x coordinates, and the y coordinates of the center would be -5. It's very, very simple. And now onto our favorite section of the video, past papers. So this is arguably the most important because now we get to practice all the things that we learned before, and as you know, practice makes perfect. So let's begin with 2021 question 4 part A. 2021 question 4 part A states that a circle has the equation x squared plus y squared minus 4x plus 10y minus 8. Now the first thing we notice when we see this equation is the form that the equation is in. So notice the form before, right? So if you go back, you realize that this is the general equation. And that is important because we know that we can easily find the center from it. But let's first read the question. Determine the center. Determine the center and the radius, okay? And all that is for 4 marks. So again, I don't know if anyone told you all this, but the amount of marks should show the amount of time you put into it. So 4 marks is like approximately 4 minutes and how much you should write for it. So yeah, this is what the solution will look like. So because it's in this form, we could say that minus 2a is equal to minus 4 because it's in this position, the coefficient of x, minus 2b is equal to 10 because it's the coefficient of y, which is where minus 2b would be, which is here, right? So now we could solve for a and b very easily. We can say that a is equal to 2 and b is equal to minus 5, and that is the center, the coordinates of the center. Now, from the general equation above, we remember the formula c is equal to a squared plus b squared minus r squared. And we have all these values except for r, which is what we want to find. So remember c as well would just be this last number here, minus 8. And always remember the sign as well. This is a minus and a minus. A minus and a minus makes a positive. So don't ever forget that. And we simplify it to get the radius equal to the square root of 37. And that's how we do part A. Now part B says to show that the curve whose parametric equations are x is equal to 3 plus 3 sine theta and y is equal to 3 cos theta represents a circle. So now let's look at the equations they gave us. First, we have to make sine and cos theta the subject of the equation. Then we have to square both the equations and then apply the identity that we know, our favorite and the most popular. Sine squared theta plus cos squared theta is equal to 1. And I know all of you all have that memorized already, so I'm proud of you. Okay, so let's square both sides. Remember, when you're squaring it, to make sure to put the square here, make sure to put the square here and not after it, unless you want to put the brackets, right? So look at how we do it here. When we add in the left-hand side to the left-hand side and the right-hand side to the right-hand side. And make sure to square everything properly. Put the brackets where necessary, okay? So when we apply the identity, we know that it's equal to 1. And then we could simplify this further to get 9 is equal to x minus 3 all squared plus y squared. And this equation is of this form. Remember, one of the forms that we learned in the beginning. And therefore, the Cartesian equation would be this. And it was that simple. So now moving on to 2019. Again, for part A, so you've seen a pattern there. A circle with equation x squared plus y squared minus 2x minus 4y minus 5 is equal to 0 has center C. A straight line with equation y is equal to 2x plus 5 intersects the circle at 2 points, A and B. Determine the coordinates of C. All right. So the equation given is of this form, right? Again, something we're very familiar with. How do we find C? Again, the same exact thing we did before. We equate and we mapping it on. So we have minus 2a is equal to the coefficient of x. What's the coefficient of x here? Minus 2, right? So then we simplify to find a. Then we have minus 2b is equal to minus 4 because that is the coefficient of y. Look again here. And then we simplify to find b is equal to 2. And there we have the center. It was that easy. And that was an easy 3 marks right there. Now we have something for 8 marks. It says to show that the coordinates of A and B are 0, 5 and minus 2, 1, and that BC is perpendicular to AC. Okay, so let's take this slowly. We need to map out keywords here first, right? So let's look at the solution. A and B are the points of intersection of the line and the circle, right? To find the coordinates of these points, we need to solve the equation simultaneously, just like how we did before in an example. We can use substitution to solve them. So what we're going to do is we're going to substitute the line into the circle. Again, we did this before, so you all should be very familiar with it. And I want you to practice it as well. So if possible, please pause the video and try it before you actually look at the solution. So yeah, let's do it. We are also going to substitute y into here and into here. Why do we do that? Because, again, we're using the method of substitution. I don't know if I ever went through that in a video before, but you all should be familiar with substitution and elimination. And the method that we're doing right now is substitution. And again, very straightforward, because all we're doing is substituting the value of y into wherever we see y in the equation. So wherever we see y here, which is twice, we just putting in this 2x plus 5. 2x plus 5, right there. Right, so now we did that, and we're going to simplify everything. Then we're grouping all the like terms, which means that when you see an x squared, you put it next to each other. When you see an x and an x, you put it next to each other, which is what we did here. You do all that, and then you simplify it. We group like terms is just because it's easy on our eyes to see. If you could do it without doing that, that's perfect as well. Now we're going to divide throughout by 5. Why? Because 5 is common. 10 becomes 2, and then the 5 becomes 1. So we have x squared plus 2x equal to 0. Simplified, we get x is equal to 0, x equal to minus 2. Now we have the x coordinates. How are we going to find the y coordinates? Exactly. We're going to substitute them into the equation of the line. Why the line? Because it's easier. That's literally the only reason. So when x is equal to 0, y is equal to 2. Multiplied by 0 plus 5, so we get 5. And then when x is equal to 2, we get y is equal to 1. Therefore, the coordinates of A and B would be 0, 5 and minus 2, 1. And that's how easy it is. Now, remember they asked here, you have to show that BC is perpendicular to AC. Okay? To be able to do that, we need to compare the gradients. Recall what we learned in the beginning. When you multiply the gradients of two perpendicular lines, the product is minus 1. So you would notice m1 by m2 is equal to minus 1. I think it was like very close to the first page or something. So yeah, looking at all the coordinates here, the gradients of AC, we calculated the gradients of AC and BC. We found the gradients of AC. Remember, we're looking at their coordinates. We calculated the gradient by using this formula. And then we find the gradients of AC to be minus 3. Then BC, remember we get in the coordinates again. We're mapping them out, seeing what's y2, what's y1, what's x2, what's x1. Put them into the formula. Make sure we remember the signs. Signs are very important. We get the gradients of BC to be 1 over 3. And then we multiply their gradients. Product just means multiply, right? So when we say we have the product, we're multiplying them. And then when you realize that is equal to minus 1, we know that they're perpendicular. Because again, the rule is m1 by m2. These being the gradients. The product of them is minus 1. Perpendicular. So I hope that is solidified in your brain now. So since the product of their gradients is minus 1, AC and BC are perpendicular. And that's the end of that question. So the next part, part 3, says to determine the equation of the tangent to the circle at either point A or point B. So we're going to look at both. Tangent at A, which is 0, 5, we have to remember that the gradient of the radius is equal to the gradient of AC. Okay? So therefore the gradient of the tangent is equal to minus 1 over m. Very easy to calculate. So we have to substitute the gradient and this into the equation of a line. So in this case, we're going to use this because, again, as long as we have a gradient on one point of the line, we use this to find the equation of the tangent at A. So easily we're able to do that and then get the equation to be y is equal to x over 3 plus 5. Now let's look at tangent at B with the coordinates minus 2, 1. We know that the gradient of the radius is equal to the gradient of BC. So the gradient of the tangent is minus 1 over that gradient as well. So it will be minus 1 over 3, and then we will get minus 3. So now we're going to substitute this and this point into the equation of a line to find the equation of the tangent at E. And we're doing the same exact thing both sides, and then we simplify. So yeah, now let's move on to 2018. The equation of a circle C and a straight line L are given by x squared plus y squared minus 2x plus 2y plus 1 is equal to 0. And the line is y is equal to x minus 3, respectively. Again, looking very familiar. Determine the center and the radius of a circle C. Now, again, question 4, part A. You're seeing the pattern, right? So again, I hope this comes in your favor. So the solution goes as such, the exact same thing we did before. We're mapping it on from the general equation. Now we have minus 2 is equal to minus 2, so A is equal to 1, minus 2b is equal to 2, b is equal to minus 1. Therefore, the center is 1 minus 1. Now from the general equation of a circle, remember what C is? C is going to be equal to this in this case. So we have minus 1, remember it will be minus C. So C would have been 1, and we put in minus 1. So we simplify, we get r equal to 1, so the radius is 1. Again, the exact same thing as before. Now part 2 says to show that 1 minus 2 is one of the points of intersection of the circle C and the straight line L. This is for 6 marks now. So to find the points of intersection of a line and a circle, we need to solve the two equations simultaneously, just like how we did before, again. And now we're going to use substitution, same thing as before. So we're going to substitute y is equal to x minus 3 into everywhere we saw y in the equation of the circle. And then we're going to simplify it to get x is equal to 2 and x is equal to 1. And now that we have the x coordinates, how do we find the y coordinates? Exactly. We substitute in them. Why the line? Because it's easier. I feel like I just repeated myself at that point. But I need to repeat myself because I need to drill it in your brain. Okay? So when x is equal to 2, y is equal to 2 minus 3, basically just substitute it into the line. Remember the line there, and then we're coming back down. So when x is equal to 2, y is equal to minus 1. When x is equal to 1, y is equal to minus 2. Therefore, the points of intersection are as such. That's how you do that part. Now number 3, for 4 marks, we are going to determine the equation of the tangent to the circle C at the point 1 minus 2. Now let's look at the solution. The gradient of the radius, we're given 2 points. So we find in the gradient of the radius, we have minus 1 over 0. The gradient of the tangent, therefore, would be 0 as well, since this is already 0. So since the gradient of the tangent is 0, this means that this is a line parallel to the x-axis. Think about it. Remember what I mapped before? It means that it's parallel to the x-axis, so it's like a horizontal line, and this means that it is 0. Let me show you all. From before, gonna be hard finding that. But yeah, the gradient is 0 when this is a horizontal line. The gradient is undefined when it is a vertical line. Always remember that. This would of course be positive, and this is negative. We're very close. Right. So because it is a line parallel to the x-axis, the gradient of the tangent is 0. And yeah, okay. So therefore, the equation of the tangent will simply just be this, y is equal to minus 2. And that's that. Now, for 2017, for part A, part 1. All right, so again, the pattern. The circle C1 with equation x squared plus y squared minus 4x plus 2y minus 2 is equal to 0. And the circle C2 have a common center. So if you find the center of this one is the same center as C2. Given that C2 passes through the point minus 1 minus 2, express the equation of C2 in this form. Again, we're familiar with this form. This being the center, HK being the center, and this would be the radius, K, right? So, C2 has a common center with C1. We state in everything that we know first. Same center. C2 passes through the point minus 1, 2. So this is a point on the circumference. So looking at the equation of C1, and we found the center the same exact way we found it before, we find the center of C1 is 2 minus 1, and because of that, we know that is equal to the center of C2. Now, we need to find the radius. To find the length of the radius, we can use the points. Remember the length of the line? Remember I told you the length of the line AB, and I put the formula. Remember that. Same thing here. To find the length of the radius, we can use these 2 points at the ends and use the length of a line formula. So we plug it in, and we found r squared is equal to 10. Okay? And therefore, we can put it into the equation. Remember the equation that we put before? It was only the first where the center is AB, is the exact same thing. So you plug in the coordinates of the center and the radius, and then you have the equation of C2. And again, it's that simple. So now on to part 2. The equation of the line L1 is x plus 3y is equal to 3. Determine whether L1 is a tangent to the circle C1 in A part 1 on page 16. Whatever page 16 is, it's just A part 1, right? So this is for 7 marks. The solution is as such. If L1 is a tangent to C1, they only will intersect at one point. Okay? To determine whether or not they do, we have to solve them simultaneously using substitution again, something we are very familiar with. And let's do it. So we're going to substitute the line into the circle, and we're going to simplify to get 10y squared minus 4y minus 5 is equal to 0. Now, if b squared minus 4ac is equal to 0, there's only one point of intersection. So that's what we have to test for. Okay? So we're finding b. Remember, again, quadratic. A squared plus ax squared plus bx plus c is equal to 0. So we can find b, a, and c. So first, b squared minus 4 all squared minus 4 ac minus 4 multiplied by 10 minus 5, not 5, minus 5. Okay? Simplify that to get 216. And because that is not equal to 0, L1 is not a tangent to C1 because they do not intersect at one point. Okay? Because this value was not 0, again, the rules in the beginning that I went over. Let's run up. The rules in the beginning, these are very important as well because you never know when they will show up. Okay? So because of that, they do not intersect at that one point.